Hello, I'm Baman Haji from the Intelligent Sensing Group at On Semiconductor. In this webcast, I will be talking to you about high dynamic range imaging with LED flicker mitigation using our Hayabusa image sensor platform's SuperExposure technology. First, I'd like to talk to you about the problem of pulsed light flicker in high dynamic range scenes. On the left is a typical automotive imaging scene with the sun overhead and a modern vehicle in the foreground. This vehicle, like a lot of modern vehicles, has its headlights based on LEDs, or light-emitting diodes. These LED-based headlights are being pulsed on and off at a rate that our eyes can't see. This is called pulse width modulation, and it is prevalent in headlights, taillights, traffic signs, and vehicle messaging systems. Where this causes a problem in imaging is that in a bright scene such as this, we typically want to use a shorter exposure time so as not to oversaturate the bright parts of the scene. But when we do that, we will sometimes capture the scene when these lights are actually off. And when you put that together in a video stream, it appears as flicker and looks like these lights are turning on and off. This can be a major problem because it's distracting to a driver that's looking at a display and seeing the headlights of a car behind them flickering, and they could mistake it for an emergency vehicle. It can also be a problem for algorithms that are trying to read what is on a vehicle messaging system and not be able to get the correct information to make safety critical decisions. Now I'd like to show you how our Hayabusa Super-Exposure technology mitigates the problem of LED flicker in high dynamic range scenes. What you see on the left is a chart that will illustrate signal intensity on the y-axis, which is what is being captured by the image sensor, and illuminance on the x-axis, which is showing you the brightness of the scene that we are trying to capture. The dashed lines that just appeared represent the noise level and the saturation level in our image sensor. These two parameters are important because those are the bounds of the dynamic range that we can capture. Our image sensors can capture the scene in what we call a low conversion gain mode and a high conversion gain mode. This allows us to get both the detail in the dark areas of the scene as well as the bright areas of the scene by using the pixel capacity intelligently and extending the dynamic range on the low end for the dark areas using high conversion gain mode. But the longer we make our exposure time, the sooner we will reach that saturation point in the low conversion gain mode. So we really need more capacity in order to capture a very bright scene. What we have done with our Hayabusa Super-Exposure technology is we have expanded the pixel capacity by more than 5 times what a traditional image sensor used in automotive applications can hold. In doing so, we have extended our dynamic range on the high end by making use of the more than 5 times larger pixel capacity. So our total dynamic range has now dramatically increased, which enables us to use a longer exposure time to capture pulsed lights without oversaturation in a scene such as the one that was shown earlier. Thank you for your time. For more information about ON Semiconductor's wide portfolio of products, you can visit www.onsemi.com or contact your local sales representative or authorized distributor.